Welcome to our video tutorial on solids and their properties. Today, we will explore the fascinating world of solids, their characteristics, and different classes of solids. Now, let's dive right in.
Solids are a state of matter that have some unique properties. Firstly, solids have a fixed volume and shape, regardless of the size and shape of the container they are in. This means that molecules in the solids are tightly packed together, giving them a high density. Secondly, solids cannot be appreciably compressed, meaning they are resistant to changes in volume under pressure. Lastly, the molecules in solids vibrate in place, maintaining their positions. Solids can be classified into two main categories: amorphous solids and crystalline solids. The differences in properties between these two groups arise from the presence or absence of long-range order in the arrangement of particles within the solid, as well as their behavior when heated.
Amorphous solids such as glass are formed rapidly, preventing the constituent particles from aligning or organizing into a definite crystalline lattice. These solids have a regular shape and do not have sharp melting points. Instead, they soften gradually and melt over a wide temperature range. Amorphous solids exhibit short-range order, similar to liquids, and are often referred to as pseudo-solid or supercooled liquids. They are isotropic in nature, meaning they have the same properties in all directions, and they do not have definite heat of fusion. Crystalline solids, on the other hand, have particles that are arranged in regular geometric patterns. This results in a highly ordered and repetitive structure, often forming beautifully shaped crystals. Examples of crystalline solids include ice, sodium chloride, copper sulfate, diamond, graphite, and sugar.
The structures of crystalline solids are built from repeating units called crystal lattices, which provides uniform surroundings for the particles and ensure that the attractive force experienced by the particles are of similar types and strength. Crystalline solids have definite characteristics: geometric shape, sharp melting point, and long range of order in the arrangement of their constituent particles. They are considered through solid and exhibit anisotropic properties, repeating their properties vary with direction. Additionally, crystalline solids have a definite heat of fusion, which is the amount of heat required to change them to solid into liquid state. Types of crystalline solids. Crystalline solids can be further classified into some different types based on their composition and bonding. The main types were metallic crystals, ionic crystals, molecular crystals, and covalent network crystals.
The next is metallic crystal. Metallic crystals are composed of atoms that rapidly lose electrons, forming positive ions or cations. However, within the crystal, no atoms rapidly gain electrons. This results in a structure where cations are surrounded by the localized electrons that move throughout the crystal. Metallic crystals exhibit various properties such as high density, high melting points, good electrical and heat conductivity, malleability, ductility, and luster. And lastly, ionic crystals. Ionic crystals are composed of ions, both cations and anion, which form strong electrostatic interaction that holds the crystal lattice together. Each ion is surrounded by several ions of opposite charge, creating a stable structure. Ionic crystals are characterized by their hardness and high melting points.